All right. So I was saying that using the chain rule, the chain rule states that the dy over the x given as dy over du multiplied by du over what? Over the x. So given the expression y is equal to, open the parentheses, as x is squared plus 2x raised to the power 4. We begin by naming the inner function, the one which is inside parentheses, as the UU function, because that's when you use the chain rule. You can only use the chain rule once you have these parentheses, or you have the radicals, like the number under the roots, some expressions under the roots. So what you do from here, this one which is inside, I've said you are going to name it UU function. Therefore, your U function will be equal to what? X squared plus what? Plus 2x. That is your U. So it simply means to find the U over the x, it means to differentiate this equation with respect to x, right? Differentiate this equation with respect to x. So how do you differentiate this one? As usual, from the power rule, you know that you just drop the power. You have 2x to the power 1, because when you say 2 minus 1, the power 2 minus 1 is just be 1. Then it plus 2 to the constant. This is the derivative for this U function. Do you agree with me?
Yes, I do.
Then from there you have the du dx. What you need now is the dy over du. So dy over du simply means now you differentiate the y function with respect to u. So this part here I've said it is u. So it means your new expression of u, y is equal to u to the power 4. So to find the du y over du, it means to differentiate this y function with respect to u. So you drop the power 4, u to the power what? To the power 3. You agree with me?
Yes, I do.
Yeah. So from there now, it simply means to find the y over dx, you just do what? You multiply these two parts now. The dy over du and the du over dx. Just multiply them together. So just multiply them together. What was our dy over du? Our dy over du was 4u to the power 3, multiplying with the du over dx. Our du over dx is what? It is 2x. It is 2x plus what? Plus 2, like that. So now, so from here we know what our u is. We know what our u is. We can replace by putting our u, which is x squared plus what? Plus 2x raised to the power 3. Multiply that by 2x. Multiply this by what? By 2x plus 2, like that. Which simply means you can write this equation as 4 times x squared plus 2x raised to the power 3 times what? 2x plus 2, like that. And the end here. You can end here. Do you get that? This is your dy over dx. Did you get it?
Yes, I got it.
Okay. The second example do better. Let's do the second example. Example number 2. So we can say, can you differentiate y is equal to the square root of 3x squared plus 2x? How do you differentiate this? So I said, as long as you find that this one is under the root, you can you need to use the what? The power rule, right? Not the power rule, sorry, the chain rule. So you can rewrite this from the rule of indices as 3x to the power raised to the second degree plus 2x raised to the power. The square root is as good as half, right? 1/2. Do you remember this rule from the indices? Maybe it's
I
been a long
remember
time. It might have been a
it
long
looks
time
familiar.
in high. Is it in grade 10 or somewhere? Where do they do indices? That's yeah. It's very many years ago. Yeah. In high school, we learned these things like that. So we can rewrite this expression like this. Then from here, we know that you can easily use your what? Your chain rule, right? How do you use the chain rule? The inner function should be named as a u. So our u is equal to what? 3x squared plus 2x, isn't it? Then we need the du over what? Over the x. What is du over the x? You drop the what? You drop the power, isn't it? Like you drop the power 2 times this 6. You have 2 times this 3 x the power 1, of course, plus 2. Okay, so this will give us 6 what? 6x plus what? Plus 2. Do you get it now?
Yes, I get it.
Yeah, so this is your du over dx. Then we need the dy over du. It means that since we have said this is our u, so it means our y will be equal to u to the power what? Half, right? When you drop the power, using the power rule to differentiate this, find the dy over du, you drop the power, you have 1/2 u, 1/2 u, 1/2 u to the power. What is half minus 1? It's negative half, right? It's negative half, isn't it?
Yes, sir.
Then, just from the basics, this is our dy over du. Now, from the basics of power rule that I talked about, you can rewrite this part as 1/2 times the u to the power negative half, right? Then we know that we know that you can rewrite this as half times from the rule of indices. This part can be written as 1/u to the power what? The power half, right? Like that part I was talking about. Once you want to leave the negative, you just say 1 over that variable. You bring the power down as a positive part. Do you get it?
Yes, I get it.
Mm-hmm. And now we still know that this 1/2 can still be written as a square root, right? We can still rewrite this just as the square root of this expression from what we had there. We know that u to the power half is same as the square root of what? Of u. Or you can rewrite 1/u. Just the same way how we did it here. Like you can raise this the square root up just like that. You're following?
Yes, I'm following.
Okay. And so from here, we know that you can easily multiply now. 1 times 1 here is 1 over 2, 1 over, like 1 over 2, the square root of what? Of u. This is our what? Our dy over du. Our dy over du, meaning the derivative of the y function with respect to u. Do you get it?
Yes, I do.
Okay. So now, according to the chain rule, we are saying that to the chain rule means you just multiply this part times this other part here. So our dy, chain rule says dy over dx shall be equals to dy over du times the du over what? Over dx. What is dy over du? It is 1 over 2, the root of u, right? The square root of u times the 6x plus 2, right? Which is dy du over dx. You got it?
Yes, I did.
Yeah. Over 1. 1 times the numerator, so you get the numerator, right? 6x plus 2 over 2, the square root of u times 1 is just the same expression, 2, the square root of what? Of u. Do you follow?
Yes, I'm following.
Okay. So that from here, what do you need? You know that, see, this u now, you know what your u is, right? You know what you said your u is. 6x plus 2 over 2, the square root of our u is what? It's 3x squared plus 2x, right? So this will be what? With y over dx. Like this will be your derivative. Any question?
No, so far.
Okay. So you've gotten the gist behind the chain rule, right? It's about the chain rule. There isn't much that you're doing. So the easiest, the thing is that you just check, you have the expression under the root. That expression under the root will be your u, right? You say let u be equal to that. Then you find the u dx. You differentiate that u function with respect to x, right? Then if you have the expression under inside the parentheses, you name that as your u as well, and then differentiate that. Then you replace the u function with u and this derive the y function with respect to u, and then you multiply the answers. Hello.
Yes, sir.
Madam Perry, we are together, huh?
Yes, we're together.
Okay. We can now talk about the product rule. We can talk about the product rule. The product rule states that if you have the expression the two expressions that multiply themselves, to find the y dx over them, for them, the y over dx thereof, you have v u prime plus u v prime. You know, u prime is the same as du, like differentiating the u function with the respect to xi, same as du dx. Like this can still be v du over dx plus u dv over what? Over dx. It's the same thing. This is what the product rule states. Do you get that?
Yes, I get it. In this case,
So,
the V is what?
yeah, okay, I'll tell you what they are. So this simply means that you have two product means what you get after multiplying, right? You have two expressions multiplying themselves. Then you name one expression with the V, then the other one with your U. That's how to start. You start by naming one expression V, then the other one will be your what? Your U. Do you get that?
Yes, I do.
So let's go on. Can we find the dy over the x when we have 3x squared multiplying with the square root of 3x minus 4, like that. Let me remove the radicand. Let me use this one now, or the power 4, like that. So now, observe that you have two words, two expressions multiplying themselves. You have this one and this one. They are different. This one is raised to the power 4. This one is just raised to the power 1. Okay. So it cannot be easy to multiply this because this one, which is raised to the power 4, it means it is multiplying itself how many times? 4 times, right? This simply means 3x minus 4 times 3x minus 4 times 3x minus 4 times 3x minus 4. You've seen what it means. So like now to expand this, it will be something that like the expression will be growing and becoming more complex and complex. So that's why you need to use those formulas that I'm trying to give. Do you get it?
Yes, I get it.
So now let's go. So the first thing that you do is to name these expressions. One the V, the other one the U. You can choose any of them. Which one would be your V? Naming doesn't matter.
The first one will be the V.
Okay, so 3x to the power 2 is your V. Then what would be your U? Your U would be what? Be open the bracket 3x minus 4 to the power 4, right? What do we need from the formula? From the formula, you need the du over dx, meaning you differentiate this u function with respect to x, right? To find the du over the x is same as to find the u what? The u prime. Okay, it's just same as finding the u prime. So what is our u prime? Our u prime. What rule can we use to differentiate this expression, the u function? So far from the rules that we have covered, which one can?
Power rule.
All right. So I said that as long as the expression, the power here exceeds 1, you can't use the power rule because power rule can just apply if this expression here, like the whole expression which is bound by parentheses, is raised to power 1. As long as you have the power that is greater than 1 here, you use the other methods. Did you get it?
Yes, sir.
Yeah. So use the chain rule in here. So how do we use the chain rule? Now we name the inner function as the what? As the u, isn't it? The chain rule. Let me solve the chain rule. The chain rule, according to the chain rule, you have u equal to what? 3x minus 4, right? Then the du over the x would what?
Yes.
When you have to differentiate this expression. What is the derivative of this with respect to x? What did we say in the power rule? So we said that as long as this variable here, x, is raised to the power 1, just get the coefficient here. That's what we said, and we demonstrated how it becomes that way. So our derivative would what? Would be 3, right? Because this one is a constant, and whenever you differentiate a constant, we said the dy over dx of a constant is 0, isn't it? So our du over the x is 3. Then you realize this is chain rule now that we're trying to do. If you've observed for this one, just for this one, to find u prime. We will relate this as y is equal to our u to the power of 4, right? Then we'll have 4u to the power 3, right? Okay, we need to find the dy over du. According to the chain rule, we need dy over du to multiply with the du over the x. So multiplying the two expressions, this one and this one, what you're going to have is multiplying these two, it will be 3 times the 4u to the power 3, right? And we know our u. We already know our u. We have 3 times 4 to the power. What is our u? Our u is 3x minus 4, right? The power 3 like that. So that you can have 12 3x minus 4 to the power 3 as our u prime now. This is derivative now, is the differential of this. That's what you're looking for. When you differentiate this, you get the u prime, right? So we were trying to differentiate this one using the chain rule. So the differential of that is 12 what? 12, open the bracket, 3x minus 4 to the power 3. So that is our u prime. Did you get that? So now that you've gotten your u prime, you have your u prime, you need the what? The v prime, isn't it? The v prime this side. Let me use the red marker now for the v prime. The v prime will be given as what? How do we do it? Drop the power, right? It will be 6x, isn't it? From the power rule. And so this implies that now you can easily do your product rule by saying vu prime plus u v what prime. That is to say, you get the v function, multiply it with the what? With the u prime. And the u function, you multiply it with the v what? The v prime. Since we have all of them, then we can start multiplying. We have all of them. What is our the formula? Is vu prime plus u v prime. We start with our v. Our v is what? 3x squared multiplying with u prime, which is 12.
3x minus 4.
Multiplying with 3x minus 4 raised to the third degree plus what's our u? Our u function is 3x minus 4 to the power 4 multiplying with what? With the v prime, which is 6x. Do you get that?
Yes.
Okay. So from here now, you can easily expand this 3 times this 4 gives us 36, right? 36x squared times 3x minus 4 raised to the third degree plus 6x times 3x minus 4 to the power what? To the power 4, like that. This is your dy over what? Over the x. If you can manage to further multiply here, then you can expand. Yeah, you can expand, but expansion here really is a lot of work. Like trying to expand this algebraic is really a lot of, but you can still end here. Do you get that?
Yes, I do.
So that's what the product rule states. That's what the product rule states. The second example you do better. The second example will do better, I think, if the first one has not done it. Can we now differentiate y? That should be equal to 2x to the power 4 multiplying with the root, the square root of 2x minus 2, like that. You've seen, as long as these two different expressions are multiplying themselves, you need to use the product party, product. So we can rewrite this as 2x to the power 4 times what? 2x minus 2 according to the power to the rule of indices, to the power half, right? Yeah. Then you can name now one v, the other one u. Which one is your v?
2x to the power 4.
2x to the power 4 is your v. And then your u will be 2x minus 2 to the power half, right? What do we need? We need the v prime, isn't it? What's our v prime? Differentiate this equation. It will give us 8x to the power 3, right? I've moved the direct now, okay? You've got to twist behind the power, isn't it? Like you drop the power, multiply, you know, those things. And then here you need the what? The u prime, which means you need to differentiate this. So now, what method can you use to differentiate this part?
Half is less than 1, so we can use the power rule.
All right, so I'll repeat this. As long as the exponent here is 1, is equal to 1, you can use power. But as long as it is not equal to 1, it can be a fraction or any number greater than 1, you use a chain rule. Did you get it?
Okay, so even when it's less than 1, you can't use the power rule.
Yes, you can't.
Okay.
As long as it is not equal to 1, that's why I said it. And if it's a fraction or or anything, as long as it's not 1, you just can't. Okay. So you need the chain rule. to differentiate this. So we're just interested in the final solution. How do we differentiate using the chain rule? The straightforward method now. Just straightforward. It's the same one, but instead of saying u, v, what, you can just move direct. You drop this power and keep this expression the way how it is. It should be half. You keep this the way how it is, 2x minus 2, like that. Then you reduce this exponent by 1, right? It will be negative half. Are you following? Drop this exponent. Yes. Then you multiply by the derivative of this inner function. You multiply by the derivative of this inner function now, which is this one. I'll shade in blue. This one. That's the inner function. So what's the derivative of this is 2, right? Is it 2? Or do you understand how the 2 comes about? How the 2 comes about?
I'm lower.
Okay, so we have used the power rule to differentiate this expression. We are differentiating 2x minus 2. I said that when you're differentiating this, you can easily use power rule here now. Once you're differentiating the expressions where the variable is raised to power 1 here, you just get the number, right? The coefficient. If you have this number, which is a constant, it doesn't have a letter, the differential of this is 0. So this is as good as you've gotten the 2 here, and this part is 0. So it just remains 2. Did you get it now? Just remember the power rule.
No, it's clear.
Yeah. So so you need to have time to go through the power rule. You've seen that the power rule is the foundation of almost everything. So you need the power rule. It's very important. Effect on the power rule. Right. And so from here, you can easily multiply. We know that there is over 1 here. So once we multiply this part times this one, we can have, what can we have? We can have half multiplying with the 2. Then you have this expression, which is 2x minus 2 raised to the power negative what? Half. Right? So hello. Are we together?
What together?
Okay. So you know that you can easily you can multiply these 2 parts here just simply by canceling this, right? You can have 1 times 2, it will be 2 over 2 times 1, 2 into 2, 1, like that. Right?
Right.
So you simply remain with this. Just remain with this. Yeah. As your what? As your u prime. So this is your u prime. This is your u prime. U prime is equal to that. So now, what do? We always multiply our u times our v, right? What was our u? Our u was the square root of what? Was the square root of 2x minus 2, right? Was that our u?
Yes, that was the u.
Which is same as to the power half, right? It is just the same as raising that to the power half. So in short, our u was the square root of 2x minus 2, like that. Then we are multiplying the u times, like we are finding vu prime plus uv what? Uv prime, right? What is our v?
The power 4.
Our two, right. You said our v was 2x to the power 4. That was what was our u prime? Like the network had tripped, then it erased everything that had written on the screen. Hello? 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 Hello?